Oh well. All right. So let's see. Test. If you haven't taken the test, make sure that you take it. But you probably want to contact me, and we can set up a review session if need be. You don't have to take it immediately. I don't want you to take it like today and then bomb it and then have to redo it. Okay. So I want you to do well on it. So if it has to be a Wednesday or something, we can set up a virtual kind of review session. We can go through it, make sure you're ready. You can take it, get a good grade on it, boost your score. Okay. If you scored lower than an 80% on it before break, or if you take it this week and you score lower than an 80% on it this week, you can do corrections up until Friday. Corrections will be due Friday. Okay, they're only available for students who scored lower than 80%, so 79 and below. You can do corrections, turn them in, and that'll boost your score. Okay, you could also do a retake. I would like that done by this Friday as well. All right, but I think most students are choosing to do corrections because it's a little less stress, because you don't just have to get one shot at it. You can study, ask me questions, and we can go through the test together to make sure that you are correcting it well and getting points back. Okay. Also, this Friday is the end of term 3, going into term 4, the last term of the school year. Okay. Term 4, I'm going to have you start fresh as far as I am going to lock down all the old assignments. So if you're constantly trying to catch up, I want you to just cut your losses, start term 4 fresh, stay current, try to not have any missing assignments or not very many missing assignments for term 4. And then halfway through term 4, I'll lock it down again. Okay, at the end of the year, if you need some points back, you're close to passing or you're close to getting from like a B minus or a C plus or an A minus and a B plus, if you're on that border, I can open up the old stuff again. You can do them then. Okay, but I don't want students, sometimes students are just focused on all the old stuff and then they just constantly never catch up because there's just old stuff and new stuff. Okay, so we're just going to cut our losses and go to the new stuff at term. All right, I think that's all I have for you as far as updates. Let's take a look here. So if you haven't yet, you can open up your Chromebooks, go to your home page for chemistry. I updated grades for you this morning. Okay, so early this morning, I updated grades for you. So Skyward should be 100% updated. Taking a look at week 9 here. Week 9, we got our to-do list for week 9. Tells you what you should do every single day. So Monday is what we're doing. Okay, Wednesday, here's what we're doing. There is a small assignment on Wednesday. I did this in about, took me about 3 minutes. I'm guessing it'll take you guys more like 15-ish. Okay, something like that. Doesn't take too long. Okay, maybe 10 minutes. Some of you who are really, really good at it by Wednesday, you might be able to get this done really quickly. Okay, and then Thursday, we will do a little kind of review at the beginning, and then we'll do some more work. Now, we didn't quite finish all 4 pages today, so some of this might get bumped to Thursday, but I'll tell you exactly what we'll be doing at the end of class, so there's no confusion. Or if you're confused, contact me, email, or in person, and I'll make sure that you're aware of what you need to do. Okay, Monday's assignment. Click on Monday. We're going to log into ClassKick. I know it's been a while. It might be like muscle memory, though. Log in. Continue with Google. Doesn't work for me. I'm a fake student. And we get here. We're going to start with a lab today. Starting with a lab. Virtual students, you have this link here. You can click to watch the lab. It's not the exact same thing we're doing, but it's very, very close. Students in here, I'll kind of get you started. Let me grab a kit. You're going to work with the people at your station. You're going to need to grab one of these boxes. It's got all the equipment in here that you need. I should say majority of the equipment that you need. Let me walk you through this. So this is an inquiry lab. I'm not going to tell you. I'm going to tell you how to set it up. Okay, but other than that, I'm not going to tell you a whole lot. You're going to have to do some research. You're going to have to figure some things out on your own. But I'll tell you exactly what to research here, since we haven't done this too often. So first, I'm asking you a question. Okay, which tube, red or black, might not make a whole lot of sense yet because I haven't shown you the lab, but which tube, red or black, has oxygen and which tube has hydrogen? Okay, that's the question that we're trying to answer. Here are some things that you need to know. Okay, you might not know these off the top of your head. That's totally fine. When you're running the lab, don't start answering them now. Okay, when you're running the lab, there's going to be about 10 minutes that you have to wait. During those 10 minutes, you can pop back up here. You can split up the work with the people at your station and find the answer to each question. Okay, then as soon it's kind of popping back and forth here a little bit. Uh-oh, what's going on here? Oh, here we go. Okay, then after the 10 minutes and the lab is essentially done, okay, then you're going to go up here and you're going to make a hypothesis. You could kind of make a hypothesis like as you're working on it, but I don't want it to be a complete guess. I want you to have at least some background on your guess. Okay, I don't want it to just be random. I want you to have some reason for it. Okay, then as the lab is running, right here, first thing you're going to do is list observations. I want you to make as many observations as possible. You should get more than just one. Get 2 or 3 observations. What do you see occurring in the lab? Okay, here at the very end, you're going to have some bubbles in some test tubes, and I'm going to walk you through all this in just a moment. And you're going to have to measure the height of the bubble, or I should say, how big the bubble is. And I'll show you how to do that in a moment. And then just kind of some questions at the end. Here are the directions on how to run the lab. So here is your water trough. Okay, right here. It's just like a bucket of water. Well, it's empty right now. You need to put 140 milliliters in here. There are graduated cylinders back there. You see the green and yellow ones. Goes up to 100, so you're going to have to do 100, pour it in, 40, pour it in. Okay? One thing to remember about glassware, since we haven't done this for a while, don't put it underneath the nozzle and then turn the water on. Because as some of you may know, that water can come shooting out of there pretty fast. It can push the graduated cylinder out of your hand and shatter it, and then Mr. Zeno happy. Okay, so turn it on, make sure it's not like blasting, and then you can fill up your graduated cylinder. Okay, put 140 in this trough. Then you're going to take this, I don't know, what do they call it? Stand assembly. Okay, we're going to put this in the water. Okay, it might not sit perfectly flat. That's okay. Then we're going to take the test tubes, and this is the hardest part right here. You're going to take the test tubes, and you need to fill them completely with the water from this trough and stand them up on this, what they call it, a stand assembly. So it should look, uh-oh, this one's broken. I'll have to get another one. Okay, it should stand up like this. Okay, it's not a tight fit, so it doesn't stand up totally straight. It just kind of like leans every so often. That's fine. Okay, so you should have 2 of them. Now, here's my hint, tips, and tricks on how to do this. Okay, just take this thing and dunk it completely in the water. Okay, you might have to tilt it, rotate it, roll it around to try to get all the air out. Then, once all the air is out, okay, you can raise it, and as long as this mouth is underneath the level of the water, it won't come spilling out. And then you get it real close, and you get it just above this little metal kind of screw here, and it should work. If you need to tip this stand a little bit to make it easier, go for it. Doing it a second time is a little bit harder, because if you tip it too much, this one falls off, and then you got to start over and whatever. Okay? So that's the hardest part of the lab, is getting it set up. Go ahead and try it on your own for a few minutes. If you're like, I can't do this, I'm just wasting time, call me over and I can help you through it. Okay? But I want you to try it. I want you to all try it on your own first. Can't do it, I'll come around and help. Okay? Then, oh, just hold on a second. You're going to have a 9-volt battery, and you're going to hook this up. Okay? Now, which side is red and which side is black is important. So make sure, what does it say here? Black goes to positive, or no, sorry, black goes to negative. So on the side of the 9-volt, it'll have a positive or a negative sign. Make sure that black goes to the negative. Then you need to add 10 milliliters of sodium sulfate. Some of these are pretty close to empty. If you're out of sodium sulfate, let me know, and I can get you some more, or I can get it running for you. Okay, and then you wait for the 10 minutes, make your observations, and you run the lab from there. What questions do you have before I let you guys get started? Okay, last thing, I forgot about this. If you complete everything on the lab, that's pages 1 and 2. Page 3, you can click on here, and you can start taking some notes, but I'd like you to take notes on paper. So if you have a notebook, use a notebook. If you don't, I have sheets up here that you can use. You can do that if you got the whole lab done and kind of get a head start. So then when I go through the labs, you can do more listening and that instead of frantically writing. Okay? All right, you guys have time. You can get started. Go! Oh, sorry. One last thing. Don't forget about gloves. You got gloves back here? Glove up, glove up, glove up. Yeah, glove up. All right, let's see here. All right, so I think I mentioned the virtual students, but you can watch this video on page 1. I'm going to get you an idea of what's going on. Still look these things up here. Still can make a hypothesis. Do that before you figure out the answer on the video. Yeah, I think he measures them in the video. You can take that. And I think the rest, I think, is doable. If you have any questions as you're going through, you can put them in the chat or email me. Oh, thank you. Oops, I forgot. One of them. Where do you put it in? Check your test tubes, make sure that you have 2 unbroken test tubes. You need water. Yes. There's actually one. You were paying attention for a while. I was paying attention. Water boy? I've paid attention. Here's a rough estimate. Yeah. What's that? Yeah. The motor is water. There is no motor. So go ahead, follow the directions right on your lab. If it's not showing up, it means let me know.
Does it look 140?
Yeah.
I would skip 40. Did you measure 140? I'm pretty sure. Well, I don't know what corner you're doing.
Put this in. You gotta make sure the water level is.
See, my red.
Yeah.
Like 10 or 5.
You got 140, right? Fancy place there. Oh, man. Yeah, and we want that.
Right.
Yeah, you just don't want to like break the wall.
Get out, Box Jim.
This under gets full.
Yeah, one moment. No. No, pass it off.
Watch. Which one is that phone?
Like all of it.
Hey, we're doing it. I'm
Yeah,
pretty sure
you-
mine
Is that there?
mine spilled all the water. Oh. Yeah, this is a fail of a lab. I say we just call it a day. That's it, wrapping up.
Air is influenced.
You should have a black
Yeah.
We're wrapping up for the day.
Yeah.
We're done. Z, like, I'm game.
That's all air.
Okay, when you
What
make
the
it, so.
freak?
Yeah, right. It's like. Water and electricity. It's fine. Leaders like
That's the right.
Right click.
Wait, go try this out.
We're dealing with electricity and water. That does not make a good combo, man.
Make sure you get up.
Yeah. Nothing happened.
Stupid.
This is not technology.
Just do it.
It's not technology. We need more of these.
Yeah, that's what you said, water.
Yeah, we don't have the extra sugar or the flavors on it.
This Josh, really?
So what is it supposed to do?
Wait, so it's your day, bro. I need to start passing this class. Not really.
So in the missing work,
House corrections if you need to. Recommend. Oh, yeah. Well, I mean, what the high school? I've been just super busy.
Oh, wait, Frank.
I see.
He's my guy. He's my dude. Please, stupid. We have to add this on so like, oh my god.
Is that so? Wait.
We've been testing.
I don't know if I would solve it. Did you stop it? Or you?
Was it at least good?
So literally.
No, this is actually the one you saw.
What?
We have right now, we have.
Any guys?
Extra clip.
I'm a mid play.
I don't know, I got very pretty hours. We got some. Which I think I can do it here.
On the line?
You just asked me.
Sulfate.
Oh, wait, you want to hear
Waiting.
Alright, cool.
Yeah, but why did you not?
Because when you look at it, you're like, kind of like, you're gonna go like, you
didn't let him go.
yeah, so when he stopped talking, Connor took up the balance. He got it all, he had like joggers, so it went all down his leg, he stuck in his leg.
It's that is so shit. It's high school football.
We have to. Do I have to restart the timer?
Maybe you're bad enough that charge. How do you know?
Oh, there's some water.
I don't see any.
Oh, wait.
Yeah, because I can see a little bit. I compliment you. You doing all right?
Dude, that's true. It's so amazing.
That makes observations.
I see water starting to form.
Never believed it
Can I take off my gloves?
I wouldn't yet. Just gotta clean up.
I'm not gonna be too cute.
You're not gonna help clean up?
What?
You're not gonna help clean up?
I got my hand in it. I'll leave this go down.
Boy, you look like a
You get over.
There you go.
Why don't you just drive it?
Until somebody T-bones you get back on insurance.
You have no insurance?
Oh, no, you got to have it registered. That's how it works. It's an out-of-state truck.
Oh, it's an out-of-state? That's why they're.
Then later on, I'll my gas.
That's a hard job.
I'm just gonna drive it without speed on the side here.
Let me say Jacob. Describe the church, right?
Is Michael all black up his stuff? Is Michael's all black up his stuff?
No, it's I don't know. That's different.
I'll do next one. If I can get to my phone and line it.
Hey, what is it? Always what that
Boy, you don't know.
You don't want to wait.
Hey, keep track about 10 minutes. Doesn't have to be perfect, all right? But it should be pretty close to 10. You need a ruler. I got rulers up here to measure. Oh, one thing. Don't measure, it says height of the bubble, but I don't want you to measure how much water's in the test tube. I want you to measure from the top down, how big is the bubble of gas. Okay?
What it looks like. My wheels look like such a slices. Michael runs it for a while. Wait, dude. So this video of lab. I'm gonna watch it. Wait, What are the elements?
Are you guys still undefeated?
Yo, I love Rick.
Like the whole team. The bunch of the whole team. You guys lost that. And that was such a I don't know. Complaining.
It's 10 minutes and 16 seconds. I didn't even.
Yeah, she told me she was practicing,
We don't know.
You're right.
Wait, what's the only number one or third?
Search.
Why get it off over here? I'm touching this battery, no. Oi. Oi.
How am I going? Imagine that.
We're losing time.
Three centimeters. What 3 centimeters? You can tell me which one's bigger, which one's smaller. Yeah.
And then you're both. Oh, we're getting one.
Red, white,
What for?
why did you speak it?
Wait, now we gotta put this away.
Hey, be careful with the battery.
Are we supposed to like,
It just takes off.
Yeah. Get a ruler.
Way top of the glass to the water level. What is the wash and steam? What did you say? You heard me. No, it's been long time. Yeah. And now I think you're actually lucky. There you go. Nice place out here. Is there more than one garage involved?
Yeah.
Well, one of these is one side grass, one is concrete.
Yeah, you think that's
It's one upstairs.
probably more for one. What do you
So why would I say that?
Because it's there, out of stuff.
So the first, the second section of the lab, where it says things you should know, use that as a guide. Use that as a guide to figure out which one. That can help you.
No one's as funny as me.
What'd you say here?
We were the thing in the world. Oh, you want the charger now? I mean,
I want to pay attention to
I'm actually working on the first page.
I got all the first page done.
Is it ready?
One thing is there was doesn't matter, just. It actually doesn't.
Oh, I think it does.
Nice. Yeah, yeah.
That's the way you presentation next hour. What do you do?
For what class?
But I did anyway. Will. No way.
Yep. Yep. Once you're done with the lab, you can start cleaning it up.
Yeah.
You want us to export the first two bits?
Yep. What time do we get out of here? 11:14. Okay. We'll do it.
Do we just like?
Yeah, did the outlets. Oh, yeah. Seamless
What
work.
is this happening?
I learned that. I learned
Once you're done, you can put the graduated cylinders in the bag and you can clean up your kids, put your kids back. We're gonna get going here in a little bit. I'm just gonna give you a few more minutes here to kind of finish up.
Mr. Teacher.
Yes.
So you pronounce this? Well, you can't say volcano. Silicone.
Yes, I clean up. As you're cleaning up, let's kind of talk quickly here on the second page, all right? The analysis and interpreting data. Okay? The black wire tube. The black wire tube was hooked up to what part of the battery? Positive or negative? Black was hooked up to the negative, which means the red was hooked up to the positive. Which tube had a bigger air bubble? Black or red? Which tube had a bigger air bubble? Black or red? Black had the bigger one? Water is made from H2O, so hydrogens and oxygens. Hydrogens have a +1 charge. Oxygens have a -2 charge. When we start talking about charges, how do opposite charges interact? If we have a plus and a minus, what do those two things do? I'll give you a hint. It's either attract or repel.
Opposite attract.
What's that?
Opposite attract.
Good. These are going to attract. Then like charges, whether it's plus and plus or minus and minus, like charges, they repel. So using this information, which gas is going to end up in which tube? Look at all this information up here. How can we use this information to figure out what gas is in what tube? Let's maybe start here. Opposites attract here. If the black is negative, it's going to attract something that's positive. Well, what's positive? Well, it's going to be part of water because it's stuck in water. What part of water is positive? The H's. So the black tube is going to attract something that's positive because opposites attract. And the H is positive, so we should have hydrogen gas In the black tube, the red tube is positive, which attracts negative, which would attract oxygen. Now, there's another way where we can figure this out too. The black bubble was bigger. Let's take a look at water. What we're doing with the electricity with the battery is we're splitting water. So if we split it, we get H2 and we get O. There's two H's here. Two H's for every one O. So if we have more H's, it should theoretically make a bigger bubble. There's a couple different ways we can figure it out. So we could use the charges, we could use the formula. But what we're doing is something called a chemical reaction. A reaction is when we put substances together, or sometimes we take one substance and we can split it apart. It's going to require some sort of energy for it to happen. And we get atoms to rearrange. Somehow they move around and they rearrange to make things that weren't there originally. So we started with water and we split it into two gases. And we could actually reverse this and take those two gases and put them back together to make water. But that would require some sort of energy. So I'm going to give you guys a minute or two here to finish this up. Okay. One thing I want to emphasize for number 9, explain in detail how you came to this conclusion. Use evidence from the previous sections in this lab and any research you did. Make sure to mention any evidence as research. Okay. So if I say positives and negatives attract, I would say as I researched before previously, I found that positives and negatives attract. Because the battery had a negative part, then the positive part of water should attract to it. Okay? Make sure you tell me where your evidence is coming from. Is it coming from the research? Is it coming from section 1 or section 2? Section 2, I mentioned that positive and negatives attract. I know that oxygen's ionic charge is negative, so it should attract to the positive end of the battery. However you want to word it. However you figured it out. You have all the information. You just need to be able to explain it in a way that makes sense to someone, knowing where you found that information. Research it. It's a common knowledge. We want to use evidence to back up what we say. Once you're done with the lab, you can export it and you can submit it for Monday's assignment. We're not going to submit the notes. As a reminder, we're going to get to the notes here in just a moment. If you need a sheet to write on, I got a sheet up here. If you have your notebook, you can open up your notebook. I'll pop up the notes here. You go to this code or this website right here, joinpd.com, and you enter this code, and it should take you right here. And if you've been taking notes already, you can move at your own pace, but I'm going to lock you back into my screen here in just a moment. So finish up your last slide. Let's see, what time is it? We also have a 7 mindsets activity today. I am nervous. I am going to forget. Who wants to be on 7 mindsets? You are, okay? Please. Yeah, my name? Yep. What time? 10:55. Okay, 10:55. You have a question? Oh. Yeah, it's just open and do it and then. Yeah.
Maybe even one.
It says that.
All right, you guys ready for notes? All right, we didn't really have any homework, so we can skip this one. Oh, I got to take you off suitcase. I'm going to lock you in. Jump. Okay, here we go. Chemical reactions. Okay, the code is still up here. So join PD for Pear Deck. Okay, join PD.com. You can put in this code and it'll be right on your computer, which might make it a little bit easier to write down the notes. Okay, so first thing you got to talk about is the law of conservation of mass. Sometimes it's called the law of conservation of matter. You see mass and matter, they kind of do the same thing. Okay, the law of conservation of mass says that mass is neither created nor destroyed in chemical reactions. Anything that has mass or anything that's made up of matter is made up of atoms. So what it's really saying is that we cannot take atoms and destroy them into absolutely nothing. We can't destroy these atoms. We also can't take nothing and make atoms from it, which makes total sense. Okay? We can't totally destroy it. We can't just create them from nothing. But what we can do is we can move it around. We can take bonds and break those bonds and recombine the atoms in different ways. And that's what a chemical reaction is. The mass or the amount of each atom in the reactants, or we'll talk about reactants in a bit. That's the things that we start with. We put things together, they're reactants. The mass and the amount of atoms that we start with must equal the mass and the amount of the atoms that we end with, or what we call the products. Atoms aren't just appearing and disappearing all willy-nilly in our universe. The amount of atoms that we have now is the same amount of atoms that we had in the past. We're not getting any more. We're not losing them. They're just changing places. So little kids, when they eat food, they're taking atoms from their food and they're rearranging them into their body, which allows them to grow. They're just taking those atoms from the food. We're not just making new things all willy-nilly. Conservation means to like keep. So the law of conservation of mass is like the law of how we keep mass, how we keep matter, how we keep atoms. So let's talk about this a little bit. We run into some issues. Let's talk about trash. What's an issue you may see with putting trash in a landfill? Why is that? I mean, it's not an awful idea, but why is that? What are some issues with that? I guess I should phrase it. Yeah. Yeah, it doesn't go away, right? The atoms in that trash, it's not like we're destroying them. Okay? They might compact a little bit. They might move around a little bit. In fact, depending on where the landfill is, sometimes those trash atoms leak out of the landfill and they can get into water. And then people drink that water. That's trash water, which is a very, very low water. Not many people like drinking trash water. Okay? So you can put something in some place, but it's probably not going to stay there. Atoms move. So we're not destroying them. We're just getting them out of our way for the time being. What about burning trash? If I have a big trash pile, we just burn it, right? What's wrong with that?
Atoms are changed and go up in the air.
Exactly. They're just moving, okay? So I burn trash, I look, I'm like, the trash is gone. It's really not gone. It's just moved. It's now in our air. It's traveling somewhere else. So it's not my problem anymore. It might be somebody else's problem. So we can never just completely destroy these atoms. We can recombine them and we can move them in different ways. We can't totally just destroy them. And so that's an issue we run into. So how do we kind of solve these issues? Well, we can't completely solve them. But instead of throwing things in a landfill or burning them, we can try recycling. Recycling is just reusing them. Now, not everything can be recycled. Okay, so that brings up an issue too. All right, but things that can be recycled, we do as much recycling as possible. Reducing. Try not to make as much trash as we do. Try not to make as much trash as we do. Some things that can't be recycled, we don't want to make them as often. Okay? One thing that just sticks out in my mind is food. All right, food brings a lot of trash. Okay, it's packaged in stores. Okay, do we really need all the packaging for that food? Well, not if it's fresh. Okay, if it's not fresh, we got to package it up because it needs to transport from one place to another. But the fresher it is, the less you need to package it. There are certain areas in the grocery store where it's just like vegetables and fruit just laying out, right? Produce. Okay. There's another section next to it, which is vegetables and fruit, but they're in containers. Plastics, styrofoam, things that can't be recycled. So what's better for our environment? We can't get rid of that trash. We're only going to move it. Okay, what's a chemical reaction? Reactions, we're going to use these chemical reactions. We're going to write out chemical reactions, and they are used to show how matter or how atoms break down or recombine. And in every chemical reaction, we're going to have something called a reactant or a reactant. Sometimes we'll have one, sometimes we'll have multiple. And these are molecules that begin a reaction. That's what we start with. And when we write it in a formula, it's going to be before an arrow. So everything before the arrow, those are all reactants. And those are things that are going to be combined. Products are what we create after it. Now, we're not creating new atoms. We're creating new substances by rearranging the atoms. Okay? So the molecules that are created after the reaction, the atoms are recombined into something new. They all come after an arrow. Now, thinking about the lab that we did today, what did we start with? What was our reactant? I'll give you a hint. There was only one thing. What was our reactant? Yeah.
Water.
Water, good. Now, we used a battery for energy, but the battery's atoms didn't like break down and recombine. We also used some sodium sulfate or some baking soda, and that was really just to speed up the reaction. It didn't really get changed, but it sped up the reaction. Otherwise, instead of 10 minutes, you probably have to wait about an hour, which would be a really long time to see those bubbles come out real slow, right? So we used the sodium sulfate or some baking soda to just speed it up. But it didn't get recombined. Products. Now, in our lab, we made two products. What are the two things we made at the end? Give me a hint, they were gases. You don't need to know what the two things we made at the end. They were gases. Yep. Good. Oxygen and hydrogen. So we took water. This is it's a specific type of reaction we call decomposition. We'll get into types later. You don't need to know that. But we start with one thing, water, and we split it into two things. Okay, it's called electrolysis. Lysis means to break or split. Electro comes from electricity. So we use electricity to split water. Water electrolysis lab. So we split the water, the liquid, into two gases, into its, sometimes people use the word components, or the things that make it up. Okay, coefficients. Coefficients, that's a number that indicates the amount of the molecule that comes after. So we could write like 2H2O. Because sometimes we don't just need one molecule, sometimes we need two. Sometimes we need 3 or 4 or 5. And that's pretty like normal. That's how we normally use numbers. So if I have 2H2O, that means that we have 2 molecules of H2O. That makes a whole lot of sense. A lot of times these reactions will be kind of associated with recipes. I don't know how many of you cook, all right, or bake. When you do a recipe, you might say like 2 cups of flour, 2 cups of sugar, whatever it is. 2 cups of something. This is like 2 molecules or 2 cups of water. It's a lot like a recipe. The subscript, we've been talking about those, but we're going to really kind of focus a bunch on those this unit. It's the number coming after a single element or multiple elements if it's in parentheses, and it indicates the amount. So now this is kind of backwards. So SO4 means that we have 1 S and 4 O's, 1 sulfur and 4 oxygens. If I do this, Fe parenthesis SO4 parenthesis 2, that means I have 2 sulfurs, 2 S's, and 2 O4s, which if you do some math, 2 O4s or 2 times 4 gets us a total of 8 oxygens. Bonus question Monday, how many Fe's would we have here in this last one? How many ions? Fe is iron. Anyone want to take a shot? Bonus question Monday. How many Fe's? Yes?
1.
1, yeah, there's no subscript that comes after it. There's no coefficient out in front of it. If it was in the parentheses, it would be 2. But it's not in the parentheses, so it's just 1. We're going to use both of these to count atoms. We need to show the law of conservation of mass. Meaning, we need to show that the number of atoms before the reaction occurs and after the reaction occurs are the same. Because if they're not the same, something's wrong because it's not following the law of conservation of mass. We're missing something. We need to constantly show that it's working. So here is an example. You can do this on, if you have a sheet, you can do it on the sheet, or you can do it right on your screen if you're writing in your notebook. So I want you to count how many ZNs, how many H's, and how many CL's are there on the left side of the arrow. You're going to write it down here. And then same thing on the right side of the arrow, ZNs, H's, and CL's. Okay? So we're going to practice here counting atoms. How many ZNs, how many H's, how many CL's? You can write it right on your screen. Then you can also type it on your screen. Probably easier just to write it. How many CNs? How many CNs are on the left side of the arrow? H's. Whoopsies. Give me about 10 more seconds. time. All right, here we go. Let's go through it. So here, let me grab my marker. Here we go. So ZNs, no coefficient, no subscript, which tells us that they're like both 1, right? Because we don't write ones in chemistry, so it's going to be 1 for a ZN. H's, no subscript, but it does have a coefficient. So I have 2 of everything that comes after. So I should have 2 H's, and I should have 2 Cl's. All right, now on this side, law of conservation of mass I should have the same amount, but I always have to double check. So here we go, ZNs, no subscript, no coefficient, so that's 1. CLs, I do have a subscript here, that's 2, so I can put my CLs in first here actually. And then same with my H's, I have a subscript, that's 2. So now I have a 1, 2, 2 here, 1, 2, 2 here. This side equals this side. So what we're going to start doing is we're going to do something called balancing equations, which I'm going to give you an equation like this. We call this a chemical equation or a chemical reaction, okay? But I won't have any coefficients in there. I'll just have blanks. And your job is going to be to go through and add coefficients as necessary to make sure the law of conservation of mass is being applied, making sure that the left side and the right side have the same amount of each type of atom. Okay, so now let's go to this page here. Okay, something that you may not have noticed, or maybe you did notice in this last one, is that we have states of matter labels. So if we go back here, we have these things in parentheses. They're not affecting anything, but they are giving us information. They're telling us what state of matter every substance is in, which is important. If I have 2 rocks and I touch 2 rocks together, they are unlikely to react. But if I melt down one rock and put the other rock in, the molten rock, they are much more likely to react. So if I have a G that stands for a gas, pretty self-explanatory, L for liquid, S for solid, but then here's the one tricky one. Aqueous means that something is dissolved. And we tend to dissolve a lot of things in water. So if it's AQ, that means it's aqueous. It just means it's dissolved in water. So salt water is a good example. Salt by itself is a solid. It doesn't always have very good reactions as a solid. But if I mix it up with water and I put stuff in salt water, now we get a lot better reactions. And that would just look like salt, which is NaCl. And then after it, it would be in parentheses AQ. So we're going to be balancing reactions, and it helps us keep track and predict where the mass moves and the chemical makeup of the substances. Okay, so when you start balancing things, you might see what you're going to make or what you're most likely to make after the things react, which is important because you can make some stuff that explodes, or you can make poisonous gases. But the mass only moves. It never gets created or destroyed. So because we're balancing things, we never have to add another substance. We just have to add amounts to make sure everything balances. And this is where we kind of ended for first period. So this is where I'm going to end today. And I will jump into our 7 mindsets, which I didn't watch the video, but I previewed it, and it's a good one. It's an important one. So I forget this. And stop recording.